Hi, so a friend of mine sent me a discussion on an Instagram thread, and he wanted me to say what I think about that. And I don't know. Let's read it, and we might see if this person who wrote on the stuff is just confused or actually a troll. So let's see. This guy just said 5 paragraphs. In every one of these paragraphs there's a problem that he thinks science has, and the last one I think he said is just a debunk. Let's see. Okay, the first one was let me find it. Okay, is saying that the sun is really big. Yeah, it is really bigger than Earth, surely, and is quite far from Pluto. Okay, it's spherical and the light shines in every direction. Okay, yeah, it does. As far as 3.7 billion miles away. I'd say we're even further, but light follows the inverse square law, which states that every meter the light gets dimmer by the inverse of the square of that distance. So I might draw you here. Here I am. Let's say that this is the source of light, and let's say it's a sphere, so every ray of light starts from there and propagates in space. But you see that if you take these two distances here, this is the distance x. I can make like a drawing here. So if this is the square at 1 meter, after another meter the square here is quite a lot bigger, and you can calculate that is exactly 4 times as big as the square the meter before. So this is the same energy. So the energy that has this square meter is the same energy that has this 4 square meters or squares. So it's the same energy, but the surface is 4 times as big, so it gets dimmer quite a lot and quite a lot faster than how it travels. But let's get back to the... Okay, I don't really get what he's asking here. He says that it's impossible that if the light from the sun reaches Pluto, 3.7 billion kilometers, miles is American, away, it's impossible that the Earth spinning 180 degrees blocks light. So I don't understand what he's asking. He is confused about the day and night cycle. Okay, so Earth is here. It's a sphere. Let's make it like this. I'm not really good at drawing spheres. But he said that the sun is really a lot bigger than Earth. So we can literally approximate the sun as a wall of light here, because it's really a lot bigger. It's not to scale, obviously. Earth is a lot further than this, but the law still applies. So the light getting out of the sun, it's always perpendicular to the surface, so it's always going like a wall of light that reaches Earth. So when the light arrives to Earth, we can say that the rays are perpendicular, because they almost are. So we can just say that 1/2 of the Earth gets light, so this is the lighter, the one to the left, and here on the right there is no light at all. We only see the sunset, which is this line here. And why? Because the rays hit Earth in these points. So these are the points where the Earth is lit up. And here, this is the last point that the rays hit. After this, they are going past Earth and we don't see them. These rays will go past and reach eventually Pluto, 3.7 billion miles away, what you want. They will hit Pluto, so light gets there. Light gets even further than that. So I think you were confused about this. So he's making examples with objects on Earth, and he's saying that if a skyscraper was bright as heck, the marble close to it isn't stopping that light from being seen. I mean, in space, light, because it's an electromagnetic wave, it can travel in void and just go where it wants. On Earth, there's atmosphere. Atmosphere is gas. It's particles. Light can hit the particles and bounce off, so that is called scattering. If light gets in the atmosphere or travels in the atmosphere, that light will go away, go in other directions. So if you enter a dark room and turn on, I don't know, you can turn on a flashlight like this and turn off this. There's still a light there, but that is it's an example. There's a light there that is hitting a wall. Hitting the wall, the light bounces off of the wall and goes everywhere else. Let's see the next thing. So he says, another example is gravity. Gravity, by theory, I don't know which one theory are you calling out, but how is it that the gravity causes us to orbit around the sun? Okay, he's confused about the motions of the planet around the sun, which might be quite complex, but let's see why planets don't come falling towards the sun. Let's say that this is a sun, and I'll use a tool for this one. Let's say that this is an orbit around the sun. They are not circular, I'll say this. They are elliptical, quite a lot similar to circles, like this. The sun is on one of the two focuses, and the planets orbit around it, so that here is the closest point to the sun, and here is the farthest point to the sun, and like Earth as one. I don't know how they call it in English, but so let's say that this is Earth, or you can see that, or you can see this as like here Earth and here's the Moon. It's the same. Just imagine an object orbiting a bigger object. So you need to account the motion of this object. You are stating the fact that yes, there's a force that pulls objects with mass to other objects with mass, and yes, there is. This force is called gravity, and it kind of works like this, is on the same directions of the two objects. So this one is the force that Earth, or the bigger object, gives to the smaller one, and this is the force equal and opposite that the smaller object gives to the bigger one. We'll talk about the first one. So let's say that this is the force. So you said that the object just falls towards the center, and that's it. That's not really it, because you need to account the fact that this object has already a velocity tangential to the motion. So you need to account the force and the velocity. These two make the orbit. So yes, the object is always falling towards the Earth, like this, but it also has a velocity that makes it not fall towards the object. It makes the smaller one always miss the bigger one. So the smaller object tries to fall, but it has enough velocity to just keep the motion, and can never fall back down to the center. So let's see the next one. Okay, it says, speaking of satellites, like before, why are all the pictures of our satellites fake? If you Google satellite, you won't see a single real picture, and all of these pictures are taken above the satellite, or Antarctica from space, Earth from space, Sun from space. They're all fake images. Okay, that is weird. Let's try and do that. Let's try and Google satellite. And are these fake? I don't know. But if they are, it's because it's quite hard to make a photo to a satellite that is moving that fast. So I'd say if these you say that are not real, if they might not, I don't know, this doesn't seem fake. But if you say that they're not real, then you do you. This looks like it. I don't know what... I don't really know. Next one, Earth from space. Okay. Again, these images looks real. This is the moon, so I don't know. So every one of these images is fake. Not a single real image. Okay. Let's do the next one. Okay, the next one is the discovered galaxies and planets light years away. Light year is the distance in space that lights travel in a year. So it's a distance. You can measure it in meters, but they're quite a lot, so you just measure it in light years. For example, you can say that the sun is something like 8 light minutes away from Earth, because lights takes 8 minutes to travel from sun to Earth, so you can use it for a distance. So he's not confused about the light year, with which I think he gets. He's confused about how camera works. Cameras are you can look it as boxes with an eye. The eye catches every single light beam that enters it and prints it on a if you have like a Polaroid, it prints it on the plastic paper. I don't know how is it made, but it prints it there. If you have a digital camera, it converts the little photons that gets there in the digital pixels, so it prints, even in that case, light that gets there. So it doesn't take 8 minutes to take a photo of the sun. You can just take out your phone, make a photo to the sun, and you see that you can make it in an instant. You can see it that the photo that you make catches the photons that are going through it, not the photons that are 8 minutes away or 500 million years. I don't know. You just take the ones that are already near you. Let me tell you this. If something happens to the sun, like it vanishes in nothingness, you won't see that for the next 8 minutes. You will continue seeing the sun where it was 8 minutes ago. So you're saying that to see something 500 light years away, it will take you 500 years. That is not correct. You can, as I said before, the sun is 8 minutes away. You can take a photo of the sun in 2 seconds. It doesn't take you 8 minutes to do one, so it's the same thing. We are seeing that 500 light years star 500 years in the past. Okay, fifth and last point. So let's see it. Example 5 is really a debunk, as I said before. but more so a question theory. The sun is a fireball basically. Fire needs oxygen in order to keep burning, correct? You might see the sun as a ball of fire, yeah, it kinda works, but it's not really like that. So yeah, his problem is that the sun cannot burn. He says that the sun should not burn because there is no oxygen in space, which is wrong. There is oxygen, but being gas, it's attracted like every other thing to objects with mass. So the sun is, yeah, it is burning. You can imagine that in some way, in the past 5 billion years ago, the sun was a big cloud of hydrogen that I don't really know the details, but you can search it. It was a big cloud of gas that compressed that much so that it started reacting, and it became a ball of plasma. Plasma is I'll let you see. Okay, plasma is another state of matter. You might remember from elementary school, I don't know what you do in America, that there are 3 states of matter. That's not correct, there's more. For example, they say that one state of matter is solid, and you can represent it like this. A solid is an object that has the particles in a reticule, so the particles are all held strongly together so that they cannot all move around freely, and this is a solid. Another state is liquid, like water. This is like ice, this is like water. Water is in a recipient. You can imagine it as a lot of particles inside the recipient that are held together by cohesion forces, but they're not as strongly attracted to each other like in a solid. They can move freely and evaporate and stuff like that. A gas is a lot similar to a liquid, but there's something more. So the molecules in a gas are quite a lot more free than the ones in a liquid. They occupy all the volume that they can, and there's almost no force between these particles. There are more of these states, and the one that I'm talking about is plasma. For example, there are different types of plasma. You might know that an atom is a really small part of an object. So an atom, you might imagine it as a nucleus surrounded by electrons. Not like that, you get punched if you see it like that, but it's similar. You can think it like this. The nucleus is composed of protons and neutrons. And in plasma, these particles are free. Not only the molecules are separated, but even the same atoms that they're composed from. Plasma is a lot like a next step. Every one of these particles that compose the atom are around each other. They're like a soup of atoms, I don't know. And so the sun was a cloud of hydrogen that compressed so much that it became that plasma, that soup of atoms, and that is really hot, really hot. So it's so hot that it generates all that heat that a star has, and it starts converting hydrogen, the atoms, in the atoms of another element like helium, like it's happening on the sun. So the sun is currently burning the atoms of hydrogen, fusing it to make helium. So it's not burning oxygen, it's fusing hydrogen atoms into helium atoms, and this creates a lot of energy, and that energy gets out as heat, as light. Let's see if he said something else. So he says here that how exactly does a scientist even explain what the sun is? There's nothing on Earth that operates in the same fashion. He's saying that if we cannot touch something, we don't know how it works. So you don't believe in atoms. We know that atoms and smaller particles exist because we can detect them using instruments, like we smash together atoms and see what comes out of that. We smash together particles and see what comes out, and we can detect them, study their mass, we can study their energy, we can, or their momentum, we can, and from that we can extrapolate what particle that is, and we can prove that it exists because it did that. It existed. If something that you don't know if exists or not does something to you or to an instrument, it means that it exists. Like you can see the sun gives energy to you, to everything else, and you say that you are not sure that the sun exists. So what do you think the sun is? So this was what I could do about that. I'm not trying to do a debunk, I'm just trying to help this guy if he needs that. I don't know if he's a troll or just he needs what I'm trying to let him know, and if he needs this, I'll try to reach out to him, and if he still continues to make other points against what I'm trying to say as easily as I can. I don't think I said difficult stuff, so I hope everyone gets this, and if that is a problem, I'll try to make another video on this. I don't know if you want, I don't know, but if he still continues to make other points and these points are not correct, then I'll just say he's a troll and close it. So I hope this works, and this was something I tried to do because I felt like it. I saw someone that didn't quite understand what they said to him, like science and other stuff, like I just said. So I felt like making this video to try and explain some of this stuff, and this got me thinking on what to do, and I think I'll make other videos like this to just seek out people like this, like people who has a hard time trying to get the stuff, and try to explain it to them, not like in a debunk, but like in a lesson. I have another episode, not really centered around a person, but around an idea, and I think it's gonna be quite fun. I'll prepare it in the future, but I'll work in editing this first, so I'll put timestamps for who wants, for every one of these points that the guy says, like I'll put 1 year for the second, 1 year for the third, you know, timestamps how it works, how they work. So I hope you liked it. I don't know, I don't really know, but see you next time.